Okay, so now let's talk about work done. So this work done over here is actually referring to your mechanical energy transfer. Okay, so whenever we say the word work done itself, we're actually dealing with your mechanical energy transfer, whether it is GPE, whether it's KE, or whether it's EPE, elastic potential energy, kinetic energy, and your gravitational potential energy itself. So the requirement for your work done itself is that there will be a force and moving it, which moves the object in the same direction as the force. So if your force is towards the right, or if your force is horizontal, your distance traveled must also be horizontal. If you have a vertical force, you will have a vertical distance for you to work. Okay, so work itself, you can see, is actually an energy transfer. So it's actually talking about energy. So work can either be expressed in W or in E. So don't use it as weight. So this W itself, sometimes if it's a bit troublesome or a bit tricky, you can just write it as work done, or you can literally just write it as energy. If not, you can just write it out in words. Your units itself would just be joules. So same thing is expressed in joules. So the formula itself is actually this. Work done is your force times distance. Just that this distance is actually your displacement in a certain direction. So it's the distance traveled in one direction. Okay, so the word over here, displacement itself, means your distance traveling in one direction. Okay, so you can basically use it quite interchangeably in this kind of diagrams itself. Okay, so below here, the requirement for you to have work done is that your force must be parallel to your direction moved. So for example, if you push your object with a force F, let's say 10 newtons, your direction traveled is towards the right, your distance traveled D, let's say is 10 meters. Okay, so you just use the formula, work done is equals to force times distance traveled in the same direction. So you can see both of them are horizontal forces. So you can just sub it in, you end up with joules. Okay, it's the same as your, if you notice the units is Newton meter, right? It's the same as joules. So normally, because we are dealing with energy itself, we simply just express it as 100 joules. Okay, so because you are using a formula over here, you must take note, they must be SI units. Hang on. Okay. So next, if let's say, for example, you're carrying an object itself. If your object is, you are carrying an object, you exert an upward force over here. Your force exerted is up. The same thing as use 10 newtons as well, and our distance traveled is now horizontal. So if you notice over here, you have a vertical force, but a horizontal distance itself. So what happens is, if you actually have your force applied is actually perpendicular to your movement itself, no work will be done. So zero work done at all. Okay? So you can just think of it as your vertical distance traveled is zero. So because of that, your formula is work F times D is your 10 newtons times zero. So you end up with a 0 joules over here. So your direction is very, very important. Now, if your direction of the force is the same as the direction of movement, both is towards the right, for example, you will have positive work done. Okay, so let's draw a box as an example. If your box is being put towards the right, and you travel a distance D, for example, what actually happens is you will have positive work done because you are moving the object in the direction that you are indicating. However, for example, we know that there are frictional forces or your air resistance that is opposing you, right? So if you notice, your frictional force in this case is to your left. It's in the opposite direction of your motion itself. So what actually happens is that we will actually call this that work is done against friction because you need to overcome your friction, okay? So then you actually have this. So if you notice, because F is now in the opposite direction, you actually be expressed as a negative number. So for example, if your big F is, let's say, 100 newtons, small f could just be, for example, negative 10 newtons, because now you're in the opposite direction. Your distance traveled is still the same. So let's say 3 meters. Okay, so do take note, what is the work done on the object and what's the work done against the frictional force. So if you're looking at the object itself, we're going to combine both of them. So there's a few things you can do. You can first find your resultant force, which is just 100 minus 10. You end up with 90. Then you want to find your work done. Force times D is just 90 times 3. So you end up with 270 joules over here. Okay? Or you can calculate all the work done individually. Work done by the 100 Newton force times 3, 300, minus away 10 times 3, which is 30. 300 minus 30, you end up with 270. You can still get the final answer from there. Okay? So basically, just take note, if you are looking at the work done on the object, it would be the total sum. If it's the work done by the person, so what's the force? Is your applied force times your distance traveled. So it's a lot of the small little keywords that is before and after your work done. Is it the work done on the object? Is it the work done by the person? Is it the work done against friction? All of these are small keywords itself that's hinting to you what to take note of. Okay, so just be very, very careful. Even though there is only one formula, work done is force times distance, there's a lot of different ways you can interpret it. So as usual, when you're dealing with your formulas itself, always make sure that you're asking about the same thing. Your work done on the box, what's the resultant force on the box? What's the distance traveled by the box, etc., etc. Okay, so let's take a look at the next page. Now, because remember, our formula is work is force times distance. If your object did not move, your distance will just be a 0. So there is no work done over here. Okay, so you must actually move the object to be considered work done. So even if you try very, very hard, you exert a lot of strength on the wall itself, that is still considered to be no work done. Okay. On the other hand, when the distance moved is now at the angle itself. So if you notice, this is your force. You have a vertical force. So what do? So the person actually traveled a diagonal path. But what we're going to focus on is we're not going to focus on the diagonal path because it's not your vertical distance. Remember, vertical force, vertical distance. Horizontal force, horizontal distance. If you have a diagonal force, then we can use the diagonal distance. So in this case, we're going to use your vertical distance over here. So if you just put in the formula, you will have 7 newtons times 4. So double check the units, newtons, meters, all good. SI units, joules. Okay? So we don't care about your horizontal distance. We don't care about your diagonal distance. Whatever direction is the force, we are the most concerned about is the force. So always identify what's the force in the formula. Is this vertical force? I'll need a vertical distance to have work done. Okay? Next one. So checkpoint number 2, example 2 over here. A father is carrying his baby home from the car park and he's climbing up the stairs. Okay? And the father weighs 600 and the baby weighs 50. State and explain. So first thing, state 1 mark, explain 1 mark, or state 1 mark, explain 2 marks. What's the work done by the father in carrying the baby when he walks from A to B? So this one is only for this part over here. Now, since he's carrying his baby, the force exerted is going to be an upward force because he needs to offset or balance the downward weights of the baby itself. So he exerts an upward force, but he moves a horizontal distance. So what is the work done? Your work done would be there is no work done. Okay? As the direction of force applied to carry the baby is perpendicular to the distance traveled by the father. Because they are in perpendicular, the force and your direction are both perpendicular to each other, you actually have no work done. Okay? So this is a 2 mark question. This is what the state. This is your state, and the rest is your explanation over here. Okay, so this is the explanation, and that is your state. So now, second part is when he actually climbs up 3 levels with his baby itself. So what's the work done by the father? So first thing, we always write the formula first, work done, force and resistance. Now the question is, what is this force? Because when he actually climbs up the stairs, he need to carry his own weight plus his baby's weight. So your total force or your total vertical force will actually be his own weight plus his baby's weight. So you actually have a total of 650 newtons, and he's going to climb up 3 stories high. 3 stories, right? So what's the distance traveled? Distance traveled, or your total distance, will just be 2.5 times 3, 7.5 meters. So all we need to do now is just put it into our formula over here. Okay, so work done is just going to be 650 times 7.5, because you move vertically upwards, 4875 joules. Okay, for some schools, they will require you to leave it in 3SF, even though it is exact over here. Okay, so that's it for this portion of work done.